Namaskar, my dear friends. Let us talk about how we can design and simulate RC filter for low pass filter. Okay, so basically we are going to design low pass filter using RC circuit. So resistance and capacitance are actually preferred in lot of digital circuits and various system designs that you will see using microcontroller and FPGA, and like a lot of circuits are there which utilizes RC as filter instead of LC or some op-amp based filters or something like that. So this is going to be very simple. We will be having one AC source and we'll be having one resistance and capacitance, and we'll see my curve is going to be a low pass filter, something like this. So basically this will be my FC, that is cutoff frequency, which is going to be the output of low pass filter. So till this particular frequency the signal will be allowed to pass, and after that it will be rejected. So let us say the outcome of this particular simulation is going to be like this. Let us say we have this particular circuit where R1 and C1 is going to set the cutoff frequency from this formula. You would be already knowing about it, that the cutoff frequency FC is equal to 1 by 2 pi RC, right, where R is 10K and C is 0.1 microfarad. So what is going to happen? Let us say if you want to increase the cutoff frequency, then either you have to reduce the value of R or C. So if we fix the value of C, then only value that can be varied is R. So as R decreases, my cutoff frequency can be increased. So for example, let us say this R1 and C1 value if we put here, so what will be my cutoff frequency here? The cutoff frequency will be 1 by 2 pi into R is 10K into C is 0.1 microfarad. So that is going to give you 159.1 Hertz. So we will see that on 159.1 Hertz, our cutoff frequency is 159.1. Okay, means it is minus 3 dB. Okay, so this is how you are going to see the magnitude plot and phase plot. So magnitude plot and phase plot is nothing but the Bode plot. So this is the AC analysis of this particular RC filter. So let us open Multisim and try to design the circuit and simulate very quickly. Okay. So alright, I have opened a new window and then I am going to place some components, right? So first of all, what do we need? Place components, and let us say we need a signal source. So I am going to take AC voltage. So let us say this is my AC voltage. Now coming back to we need one ground as well, so we'll put one ground from here. So ground is done. Then we will be needing one resistance, so go to basic, then put it resistor. So let us say I'm going to put 1 kilo ohm resistor. I can change the value by double clicking it, not a problem. Similar to that, I can press on capacitance and put capacitor. Press Ctrl R to rotate this and then place it. Then to wire this up, what you have to do is you have to go to the tip of the pin. Okay, once you go to the tip of the pin, the color changes. So quickly you just click it and it will keep on wiring up. Okay, so like that you can wire up very nicely. Understood? So my circuit is wired up. Now I will change the value of capacitance to 0.1 microfarad, and this one I will change it to 10 kilo ohm. And the RC output that we will try to see here must be what? It should be 159.1 Hertz, right, as we calculated. So why don't we do one thing? We will set the AC analysis parameter. So for that, first of all, we'll put one voltage probe here so that we can see the output. And let us go to simulate, analyze and simulation. Go to AC sweep, and in this you can set the frequency range up to what you want to simulate. So I'll simulate it to, let us say, 500 megahertz, and we'll keep sweep type as decade, and the vertical scale will keep as decibels. Okay, like dB we want. So that's all. So this you save it and then you run it. So what is going to happen is let me increase this size. Okay, so I'll just like take the trace width little thicker so that you can have a proper understanding of traces. Okay, all right. And if you want, you can keep grid on, so that grid is on and you can see it is logarithmic scale. This is my frequency and this is my dB scale, right? So I told you that the cutoff frequency will be 159 Hertz. So you can see at more than 100 there is a reduction in the magnitude. If you want to see very quickly, right click it and switch on the cursor. Okay, so there is something called as show cursor. So as you can see, the cursor is shown, and this cursor you can bring it here to make it see. This is Y2 minus 3.3 dB and the frequency is 169, right? So this one you have to bring it to 3 dB and see how much is the like this thing. So you can see around 2.8 it is. So slowly you can, yeah, so it is 3 dB. Exactly, I cannot bring it. So anyway, this is fine. All right. Let us open Excel, and what we will do is, this is my 10 kilo ohm and this is my 0.1 microfarads, 159 hertz you got, right? What I'm going to do is I'm going to change to 1 kilo ohm. Okay, so then this will become 1591, that is 1.59 kilohertz, right? So my output will be 1.59 kilohertz if we change the value of R, right? So let us change that. So change the value of, like you are going to reduce the value of resistance, it means what will happen? The cutoff frequency will increase. So let's run it, and you can see the cutoff frequency has gone here. So just bring it here and you can see this will change to minus 3 dB. That is my like intention. Okay, so at 3 dB, yes, you can see 1.59 kilohertz and this is minus 3 dB. So this is how you can simulate and see what is your output for your low pass filter. Understood? So alright guys, if you do have any questions regarding the designing of RC filter for low pass filter, you can put that into picture. And if you want to change the sources, you can double click it and change the voltage peak or its frequency, whatever is there that you want to like simulate, you can do that. And the reason why I'm telling you this is, the frequency of this particular source must be lower than the cutoff frequency of this particular RC filter. Otherwise, it will not be allowed to pass. That's the reason I increased the cutoff frequency to 1.59 kilohertz. Thank you.